Hello everyone, welcome back to my channel Learn with Simran. In this video, we are going to talk about z-scores. If you are working with data, z-scores are incredibly useful for identifying how far a specific point is from the mean and if it is an outlier. We will break down what z-score is, how to calculate it, and its use cases with example. So let's not delay it further and get learning started. So what exactly is a z-score? A z-score is a measure of how many standard deviations a data point is away from the mean of the dataset. It helps you understand whether a data point is a typical or unusual compared to the rest of the data. Here is the formula to calculate the z-score, where x is the data point, mu is the mean, and sigma is the standard deviation. To interpret, if the z-score is 0, the data point is at the mean. If it is positive, the data point is above the mean. And negative, the data point is below the mean. Let us see how to calculate z-score for a dataset of test scores using the formula we just discussed. First, we will calculate the mean for the dataset of test scores. The mean is the average of all the data points. To calculate it, we sum all the values and divide by the number of data points. And we will get 77.5 as the mean value for the test scores. Next, we will calculate the standard deviation. The standard deviation measures the spread of the data points from the mean. First, we will calculate the variance and then the standard deviation. Calculation is mentioned on the screen for your reference. We will get 11.24 as the standard deviation. Next, we will calculate the z-score for a score of 90. Data point is 90, so 90 minus the mean, which is 77.5, divided by standard deviation, which is 11.24, and we will get 1.11. This score is 1.11, standard deviations above the mean. Another example, we will calculate z-score for 60 and we will get minus 1.56 as the z-score is 1.56 standard deviations below the mean, making it a bit lower than the average score. Now that we have seen how to manually calculate z-scores, let us move to Python, where you can easily calculate z-scores using libraries like SciPy. Here's the Python code to calculate z-scores for our test scores dataset using SciPy. When you run this code, Python will return the z-scores for each value in the dataset as follows. This gives a quick way to see which data points are above or below the mean and by how much. Now let us look at some real-world use case for z-scores. The first and most common use case is outlier detection. An outlier is a data point that differs significantly from the rest of the data. Typically, if a data point has a z-score greater than 3 or less than -3, it is considered as an outlier. For example, in a company's sales data, if most sales range between $100 and $200, but you have one transaction that worth $1,000, the transaction will likely have a very high z-score and be identified as an outlier. Handling these outliers is crucial because they can distort analysis results. In some cases, you may want to remove them, while in others, you may need to investigate why they occurred. Another important use case of z-scores is in data standardization or normalization. When working with machine learning models, features often have different scales. Z-scores help normalize these features by converting them to a standard scale with a mean of 0 and a standard deviation of 1. For example, if you have features like income and age, they have different scales. By standardizing them using z-scores, both features will be on the same scale, which can improve the performance of the machine learning algorithms. Z-scores also allow us to compare data points from different datasets or distributions. This is useful when the datasets have different means and standard deviations. For instance, If you're comparing test scores from two different exams with different grading systems, you can convert each score into a z-score to see how students performed relative to their peers. In this scenario, a z-score of 1 in both exams would indicate that a student performed better than the average in both, regardless of the exam format. Z-scores are also widely used in hypothesis testing to determine if a sample mean is significantly different from the population mean. For example, suppose you are conducting a clinical trial and want to know if a new drug improves recovery time compared to the standard treatment. You could calculate the z-score of the trial results to determine whether the difference in recovery times is statistically significant. In conclusion, z-scores are an essential tool in data analysis. They help you understand where a data point stands in a relation to the mean and are valuable in outlier detection, standardizing the data for machine learning, comparing values across different datasets, and hypothesis testing. Using z-scores can help you clean your data and ensure more accurate analysis. So make sure you are familiar with them. In case if you have liked this video, do like, share and subscribe to my channel Learn with Simran. Thank you so much for watching. Keep learning. Bye bye.